Now let's go through the chemistry of halides. Now these are the halides of group 5 virtually. They are reactions with water. These are very very not the most intuitive, but they are pretty questioned quite a lot. Ammonium chloride reacts with 3 water molecules to form ammonia and 3 molecules of hypochlorous acid, which is a good bleaching agent. Phosphorus trichloride, it reacts with 3 water molecules to form H3PO3 and 3 hydrochloric acid molecules, while PCl5 reacts with 4 water molecules to form H3PO4 and 5 hydrochloric acid molecules. If it reacts in a 1:1 ratio, however, it will form POCl3 and 2 HCl molecules. The reaction between arsenic trichloride and water is similar to that of phosphorus trichloride, as it will form H3ASO3 and 3 HCl molecules. Now these two reactions are pretty unique because it will produce SbOCl and BiOCl, which are white in color, and hydrochloric acid. So basically these are the only two compounds which you can add in water, and it will make the water white color. These two are the compounds that can do that. Now we'll talk about adding halogen gases in water. So basically, if I add fluorine in cold water, it gives me hydrofluoric acid and oxygen. If I were to add fluorine into hot water, it will give me hydrofluoric acid and ozone. If I add chlorine in water, it forms hydrochloric acid and hypochlorous acid. While if I do it with bromine and iodine, nothing happens. It just forms a lame equilibrium. Now, what if we add the halogens into base? Well, any halogen gas you add it in a base, it will form the respective sodium halide, because here it's the sodium, so we use sodium hydroxide. So if we add a metal hydroxide, it will form the metal halide, and it will definitely form water. And depending on whether you add cold dilute metal hydroxide or hot concentrated metal hydroxide, you will get different products. For fluorine, if we add dilute sodium hydroxide, we will get F2O. Well, if we will get oxygen, however, if we were to add hot concentrated NaOH. If we were for the other compounds, if we were to add for the other halide gases, if we were to add sodium hydroxide or any metal hydroxide for that matter, we will get NaOX in that formula, like NaO and the halide. In this case, NaOCl, NaOBr, NaOI. But here, if we add a hot concentrated metal hydroxide to the halogen gas, we will get NaXO3. So as in NaClO3, NaBrO3, NaIO3. I think we have discussed the oxoacids of halogens in the previous episode, so like, yeah, you can look at that to see how those work. And this is the chemistry of halogens.